All right. Today, let us answer paper 5 questions, summer 2016 5-2, question 1a, question 1b. So again, let us analyze again. If you analyze, right, so a more reactive metal will displace a less reactive metal from a solution that is solved. The solution is exothermic, keyword right there. Okay. Now, if the same reaction is placed in an electrochemical cell, then the cell voltage can be measured. Okay. So instead of an enthalpy change, electrical energy is produced. So a cell voltage can be measured. Now, I want you guys to reflect back, as you know, your E cell. Remember your E cell? I want you to remember this. So when we talk about the feasibility of reactions, right? Remember what do we say? The more positive the cell voltage, the more feasible the reaction is. Now, we can link this right to that statement right there, right? If instead of enthalpy change, electrical energy is produced. Therefore, we can say that the more exothermic the reaction is, the more positive the cell voltage. Okay, so therefore, think about it. The more reactive it is, the more exothermic it becomes. But now, since they put it in electrochemical cell, the more reactive it is, the more cell voltage you produce, the more positive the cell voltage. Okay, so now you are asked to investigate the reaction of 3 different metals with this copper 2 sulfate. You will need to see whether there's a relationship between the cell potential value and their enthalpy change. Okay. Right. So now we're going to have magnesium, iron, and zinc. Okay. So because the key idea is they want to relate cell potential value with enthalpy change, okay, so they're going to give you 3 different type of metals to react with copper 2 plus. Okay, they're all more reactive with copper 2 plus. So just now, what did we mention? The one I mentioned is that as E cell increases, what does this E cell increases means? Means becomes more positive. Okay, so the delta H will be more exothermic because both of those reflects that the whole metal is more reactive. So therefore, what you need to write right here is that as the E cell increases, delta H will be more exothermic, the metal is more reactive. Because that's the idea behind it all. Okay. Okay. Next part. When determining, okay, they want you to put your independent and dependent variable. Okay, now please remember independent variable is the x-axis, the one that you modify the factor. The dependent variable is your y-axis. Okay, okay. Now, because of the x-axis, right, they want to look at the E cell. But you cannot put the E cell because your variable or your independent dependent variable must be observable. Therefore, your x and y axis, right, whatever variable you do there, right, must be observable or for this particular measurable or observable. Okay, so for the first one, because you're changing the metals, so it's type of metal. The second one, right, technically speaking, you can use something like volume of copper 2 ions loss or mass of metal ions form or things like that. But what is the keyword just now? They just now are trying to see the relationship between cell voltage and uh, and enthalpy change. And enthalpy change can be clearly represented by temperature change. The more heat released, the more exothermic the enthalpy change. Okay, thank you very much.